to do is look at example 2 from the textbook. And what they have here is for you to solve the system of equations by graphing. Now they give you two equations, but notice that they're not both in standard form. So they tell you to write each equation in slope-intercept form. I noted over here the first equation to do that, because they don't show you the steps, is to subtract 2x and divide by -1. The second equation, be careful, it's not in standard form, so we are going to be subtracting the 5x and dividing by 2 to put it in that form. Now, I'm not a big fan of the decimals, so we'll talk about that in just a minute. Then what we want to do is when we graph the equations, okay, we're solving by graphing. So the first thing we need to do is figure out what the slope is. The slope is the number in front of the x, y equals mx plus b, so that's 2. And the y-intercept is a +1. So there's our equation. We come over here to the graph, and I've shown you here we have the y-intercept of 1, and the slope, you can count up 2 and over 1. You can count, well, they counted down 1 and over a half, which is also okay. You can go down 2 and over 1, but there is something missing, and it's very important, and I always harp on, you've got to have arrows on the ends of your lines. Exactly. All right. So then we go to the second equation. We want to rewrite the equation because decimals are not as easy to graph. It's much easier if you leave slope in fraction form. So we change -2.5 to -5/2, and the slope is then, let's put that in here, -5/2, and the y-intercept is, be very careful, -8. And so when we graph that, again, we have a y-intercept, of -8. That's right there. The slope, we can go down 5 and over to the right 2, or we could go up, let's see, it's hard to see, 1, 2, 3, 4, 5, and then to the left 2, which gives us our negative slope. Whoops, didn't mean to do that. But again, what we have to do is have our double arrows. Okay, and the whole idea is that we don't just want to graph two separate lines, we want to put them together. So when we put these two equations together on one graph, this is what you should have. Here is y equals -2.5x minus 8. This blue one right here is y equals 2x plus 1, and we have an intersection point of, -2, -3. It's very important, and I took this also from the book, that you substitute the coordinates in and make sure that it works not just in one equation, but both equations. Be careful to plug x and y into the right spots. This was not in standard form, so be careful not to get them in the wrong order. And then you can check your work and you find that it works in both equations. So yay, we're done.